times. Oh, yeah, mistaken here. The insurance, if they die, they ate minus 249. That's important. Plus a negative value where you could subtract it. So I got to try that again. 530 times 0.99791, 0.99791, 0.99791 minus 249470 times 0.00209, $7.50. Remember to give me units in this case. That's dollars. Okay. According to the Air Travel Consumer Report, 11 largest air carriers on time percentage 79%. Okay. So construct a probability distribution for the random variable x. Probability distribution looks like, we could go back, looks like that. X and the corresponding probability. So that means x corresponding probability. So there's 4 flights. So what can happen if you have 4 flights coming in? Well, x, remember now, this is a probability distribution, so x is always a value. So 4 flights are randomly selected. The number of on-time flights is recorded. So what could x be? It could be 0 on time, 1 on time, 2, 3, or 4. Okay, and then the corresponding probability. Well, shoot. That means I got to do. Okay. So how do we do this? This is, first of all, we have to recognize this is a tough question. Why is that a tough question? Because I'm asking you to calculate 1, 2, 3, 4, 5 different probabilities. All right. So that means I'd have to go to my formula sheet, and I wouldn't make you do this on the test. It's pretty good practice for a review. So I would have to go to my formula sheet. Well, let's just do one of them. Okay, so I'll leave this a little bit blank, but give you the idea. And when I say do one of them, I'm going to do this one. What's the probability? Exactly 2. And I want you to show a little bit of work here. So what you need to do is realize this is binomial. That's really important. Binomial, those 2 things can happen. It can either be on time or not on time. So I would flip to my formula sheet, and my formula sheet would have the following formula. It would look something like this. And choose x, p to the x, and q to the n minus x. Okay, so you got to interpret that. So that means I'm going to say, well, that's going to be out of the 4 flights, 2 of them were on time. The probability that they're on time is 0.79 to the 2, and then what's q? Remember, q is always 1 minus p. So in this case, it's just the complement, right? So in this case, that's going to be a 0.21. And that's the other event, which would be 4 minus 2, which is be 2. Okay, so that's the answer to question A, but that also helps me to start build my probability distribution. So let's see, how do we want to do that? We'll use our calculator. So remember, you got to be able to find this button. You need a calculator that performs that. On my graphing calculator, it is under math, probability, and then I go with and choose R. I don't need that. I don't need it now. I'm just making a video.
Okay.
But thank you.
I'm sorry, I forgot to set it up.
No. For next week. Next week I'll use it.
Gotcha.
Yeah, today I'm just making a lecture.
All right.
Yeah. Thanks, Greg. Sorry about that. So let's see. 4 choose 2 would be what? 4 math probability choose 2. There are 6 ways to do that. Now you don't have to write all this down, but let's see. I can show you each one to see if you're doing this right. So that's 6. 0.79 to the second is 0.6241, 0.6241, and 0.21 to the second is 0.0441, 0.0441. Those are those three numbers. They got to, of course, multiply them together. Times 0.6241 times 6, and the probability, remember, these should always be between 0 and 1, 0.165. 165. And that's the answer to question A, 0.165. Okay. So let's see. I don't want to do all these. I don't want to make this video too long. I'll post the rest of these answers. Exactly 2 out of the 4 are not on time. So that would just be the complement of that. So that's 1 minus 0.165 equals 0.835. 0.835. What's the probability at least one is on time? Oh boy. So we do have to do this to answer that. So I'm going to pause this video. I'm just going to knock these out real quick and see if you get the same answer. Okay, so I actually answered this question. So I just used this formula 5 times, right? And that's my probability distribution right there. It's probability that it's 0 on time, 0.004, probability exactly 1 on time. And I can answer this question C. At least 1 is on time is 1 minus the probability that it's none. Right, but I already calculated that using this binomial formula, or the old way we did it was 1 minus probability that none is on time would be none is on time that at least 1 is on time. Yet 1 minus the probability that none are on time is 0.21 to the 4th, right? That's how we did it the old way. But that should give us the same answer as just adding up all of these guys down here, right? That is, at least 1 could be 1 or 2 or 3 or 4. If you add all those probabilities up, it's pretty close to 100%. I'm going to get 0.9996. And if I add 0.04 to that, I should get 1. Okay? Sorry, this video is getting long. Find the mean and standard deviation, interpret each. Okay, so mean and standard deviation. I go to my formula sheet. The mean, there's 2 ways to do this. Because it's binomial, I just have to do NP. I could do it the old way and multiply all those guys together. That times that, that times that times that, right? But because this is binomial, I can take shortcuts because there's only 2 outcomes. And then if I go to my formula sheet, the standard deviation is NPQ. Okay, so remember, this is still with n equal 4. That's important. So if I have 4 flights with the probability of on time being 7.9, then that means on average 3.16 are on time. Right? On average, 3.16 flights are on time. Standard deviation, okay, so this one's a little bit more complicated to interpret. The math is pretty straightforward. 4, so be careful when you calculate. I'm going to do what's under the radical first. 4 times 0.79 times 0.21. And you hit enter. And I take the square root of that. Square root of that. And I get 0.815. 815. Okay, interpretation is going to go down here, and I'm going to say, what does that mean? So, on average, remember, standard deviation is an average, right? It's how far away you are from the mean on average. So, on average, each flight varies from the mean of 3.16 by 0.815. So on average, on the average on-time flights is 3.16, but that varies on average by 0.815 flights. Might be a little bit better way to say that. 6, sorry about that. That's chapter 8. Sampling distributions is chapter 8. I just realized that isn't a question for us. Okay, so don't worry about that one. Sampling distribution is not something that we do. I saw that up at the top here as well. 5 through 8.1, that's my old review. This should be 5, 6, and 7 only. So I have a couple questions on here through 8.1, so I hope that didn't scare you too much. I'm going to stop this video because it's getting a little long, and then one more video for the last page.